Good morning, dear student. This is class 12 and I am Anjali Singh. Now, today's topic is potential energy of a magnetic dipole in a magnetic field. Means how much potential energy is acting on a dipole when it gets in a magnetic field. कितना potential energy act होगा उस dipole पे जिसको हम किस में रख रहे हैं इन अ मैग्नेटिक फील्ड. ठीक है, तुम्हारे सिलेबस से एक चीज एक्सक्लूड हो गई है. सिलेबस से जो एक्सक्लूड टॉपिक है दैट इज टॉर्क एक्टिंग इन ऑन अ डायपोल इन अ मैग्नेटिक फील्ड. ठीक है, वो एक्सक्लूड हो गया है, इसीलिए मैं उस टॉपिक को नहीं ले रही हूँ. लेकिन जो लास्ट पॉइंट है उस टॉपिक का मीन्स द टॉपिक ऑफ टॉर्क एक्टिंग ऑन अ डायपोल इन अ मैग्नेटिक फील्ड वो मुझे लेना होगा. ठीक है, वो सिर्फ वो एक लास्ट पॉइंट मैं लूंगी इसमें, लेकिन पूरे डेरिवेशन को मैं नहीं समझाऊंगी क्योंकि वो एक्सक्लूड हो चुका है. ठीक है, सो हाउ मच पोटेंशियल एनर्जी इज एक्टिंग. This potential energy is active. This potential energy is acting actually due to the this energy is acting on a dipole due to its position. This energy is acting on a dipole due to its actually it is a in a position means एक particular position पे कितना potential energy act होगा. Okay, particular position that I will explain you at the end of this derivation. ठीक है, means वो particular positions में लूंगी. ठीक है, जहाँ पर potential energy क्या होगी act होगी, stable होगी, कभी unstable होगी, कभी zero होगी. ठीक है, so this potential energy possessed due to its particular position. Okay, when a dipole is kept in a magnetic field. So now this torque tau is equals to mv sin theta. Means when a dipole, this m is a magnetic dipole, b is the strength of magnetic field and this is the torque tau. Okay, so when a dipole kept in a magnetic field, when a dipole kept in a magnetic field or when a dipole kept in the direction of magnetic field, so torque is acting on a dipole. ठीक है, जब इस डायपोल को मैं मैग्नेटिक फील्ड के डायरेक्शन में रखूंगी तो वहां पर क्या एक्ट होगा, तुम्हारा टॉर्क एक्ट होगा. क्लियर स्टूडेंट? So what is acting? Torque is acting. Now this torque tends to align this magnet. This torque tends to align. अब मैं मैग्नेट नहीं बोलूंगी, डायपोल बोलूंगी क्योंकि यहाँ पर दो पोल है. This torque tends to align this dipole in the direction of magnetic field. मतलब ये टॉर्क ही है जो मैग्नेटिक फील्ड जो डायपोल को मैग्नेटिक फील्ड के डायरेक्शन में रखा हुआ है. Clear student? ये torque ही है. Okay student? So this torque tends to align this magnetic dipole in the direction of magnetic field. Clear student? Now, if I have to change this dipole, if I have to change this direction of dipole, okay, so direction of dipole against the magnetic field. If I have to change the direction of dipole against this magnetic field, okay, against this magnetic field, so what has to be done? Work has to be done. Okay, अगर मैं इस डायपोल को मैग्नेटिक फील्ड की डायरेक्शन से चेंज करूंगी तो क्या एक्ट होगा वहां पर? वर्क. ठीक है, क्या एक्ट होगा यहाँ पर? वर्क एक्ट होगा. सो this amount of work done, how much work is act or how much work done is possible to change the direction of dipole in the direction or from the direction of magnetic field is known as work done. Okay, and this work done, student, this work done is stored in the form of potential energy. Now it is understood to you how this potential energy term introduced. ठीक है, so when this dipole changes its direction from the magnetic field, so what has to be done? The work has to be done. When it change in a small amount, so a small amount of work has to be done. When it is changed in a large amount, so large amount of work has to be done, and this work done is stored in the form of potential energy. Now, dW. First, we will start with small work done. Small work done. Okay. dW is equals to tau d theta. Clear, student? So, dW is equals to, the value of tau is mb sin theta d theta. अब this work done is in a large amount. अब work done कैसा हो रहा है? Large work done has to be done. तो क्या हो जाएगा? This d is going to be this side, means differentiation converted into integration. तो क्या करना पड़ेगा? Integrate करना पड़ेगा. ठीक है? mb sin theta d theta. यहाँ theta 1 रख देते हैं. कितने एंगल से ये चेंज हो रहा है? From theta 1 to theta 2. Clear, student? So now this mb comes to outside. Okay, outside, and what has to differentiate? Sin theta, theta 1 to theta 2 d theta. You know what is the value of integration of this? सबको पता है integration? पता नहीं है तो पता होना चाहिए. Integration of sin theta will be minus cos theta. Integration of sin theta is minus cos theta. This should be from theta 1 to theta 2. Clear, student? Now, this w is equals to minus mb cos theta 2 minus cos theta 1. Clear, student? ये समझ में आया? This is the numerical term only. Now, if I will change the direction of this theta 1, okay, if I will change the direction of theta 1, तो क्या हो जाएगा? Direction of theta 1 को मैंने क्या कर दिया? This dipole should get changed little bit with the at an angle of 90 degree. मैंने इसे थोड़ा सा change कर दिया. मैंने theta 2 को क्या assume कर लिया? Theta angle रखा, and this theta 1 should be 90 degree. मैंने इसे 90 degree पर turn कर दिया. ये क्या हो जाएगा? dW is equals to minus mb. ये cos 90 हो जाएगा. ठीक है? ये cos 90 हो जाएगा. cos theta 2 minus cos theta 2. सॉरी, यहाँ पर cos theta 2 के साथ मुझे cos theta 1 भी लिखना पड़ेगा. ये theta 1 is not a single term, which is a cos theta 1. Clear, student? तो ये क्या हो जाएगा? cos 90. तो ये कितना बन जाएगा? cos theta. Directly मैंने वैल्यू लिखी. Now I am going. Okay, this work done is stored in the form of potential energy. ये मुझे पहले करना था, but okay, let me U कर दिया मैंने इसे. अब मैं इसे किस फॉर्म में लिख रही हूँ? माइनस mb cos theta. Clear, student? Now, this I am going to write it in the form of vector. कितना हो जाएगा? माइनस m dot b. This is a cos theta, so it is a dot product. This is a cos theta, so this is your dot product. Clear, student? This is your dot product, so it is. तो क्या लिख दिया मैंने? माइनस m dot b. This is your final expression. Numerical you will do from this way. Okay, यहाँ से आपको numerical करना होगा. समझ आई सबको? U is equals to minus mb cos theta. Now, अब मुझे क्या करना है? Cases ले लें. Cases. So cases 1. First case आपका क्या बोलता है? First case is saying when we will keep this dipole, when we will keep this dipole perpendicular to the magnetic field. When we will keep this dipole, magnetic dipole, perpendicular to the magnetic field, it means theta is equals to 90 degree. Okay, so how much work has to be done, or how much potential energy? That will be minus mb cos 90. Cos 90 will be 0, and the potential energy or work is done, that will be 0. Clear, student? How much work has to be done? It will be 0. Now, this is your case 1. Now I am going to do the second case. Second case means theta is equals to 0 degree. अभी मैंने theta is equals to 0 degree means when the magnetic dipole is kept parallel to the magnetic field. Theta is 0 degree means dipole should be kept in the direction of magnetic field. So u is equals to, this is u, okay, minus mb. Directly manipulate you. Cos 0 will be 1. So this will be minus mb. So this will be in the position of stable equilibrium. Stable equilibrium. This is the position of stable equilibrium. Means when the dipole is kept, when the dipole is kept in the direction of magnetic field, and this time you are getting the minimum value, means minimum work has to be done. मैं थोड़ा सा लिख रही हूँ, मिनी से लिख रही हूँ, okay? Minimum work done in when you will keep this dipole in the direction of magnetic field, minimum work has to be done. Clear, student? Now we are talking about third case. केसेस में 0, 90 डिग्री और 180 डिग्री लेने से कुछ नहीं होगा. तुमको मीनिंग पता होना चाहिए कि कब किस तरफ लेने से क्या मीनिंग निकलेगी. ओके स्टूडेंट? सो now here theta will be 180 degree. 180 degree means, yes, 180 degree means when the magnetic dipole kept anti-parallel. वहाँ parallel था, anti-parallel to the magnetic field. When anti-parallel means u is equals to cos 180 degree means, cos 180 degree means minus 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 कैंसिल हो जाएगा, बचेगा कितना, u is equals to mb. और ये कैसा हो जाएगा स्टूडेंट, मैक्सिमम. यहाँ पर मैक्सिमम वर्क हैज टू बी डन. यहाँ पर मैक्सिमम वर्क हैज टू बी डन, और यू आर गेटिंग द मैक्सिमम पोटेंशियल एनर्जी. एंड this is the position of unstable equilibrium. This is the position of unstable equilibrium. Sorry, I didn't rub the blackboard because only this much topic is there. Okay, so today is up to here only. Okay, so the first case 90 degree when it is kept perpendicular to the field. Second, when it is kept in the direction of magnetic field. Third, when it is kept anti-parallel to the magnetic field. So in the first case, your potential energy will be 0. Work done is also 0. Here, potential energy will be minimum. Work done is also minimum. Here, the potential energy will be maximum, and the work done should also be maximum. And it is the case of unstable equilibrium, and this is the case of stable equilibrium. Clear, student? So ये वैल्यू तुमको पता होनी चाहिए, because it is not given in your syllabus. That is why I didn't explain this. मैंने सिर्फ इतना ही समझाया कि किसी भी डायपोल को अगर मैं मैग्नेटिक फील्ड में रखती हूँ, किसी भी डायपोल को अगर मैं मैग्नेटिक फील्ड के डायरेक्शन में रखती हूँ, तो क्या होता है, the dipole experiences a torque. The dipole experiences a torque. Clear, students? So this is all for today's topic. Some numericals is also based on this topic, so please do it carefully. And from tomorrow I'll start some important topic. Okay, this is also important, but this is easy. And from tomorrow I'm going to start magnetic inclination, okay, declination, angle of dip. These are little bit, very strange topic to you. Okay, so from tomorrow I'll start that topics. Okay, student, earth magnetic field. So, and little bit interesting also. So students, so please do it, revise it at your home, and do some numericals also which is based on that. Okay, thank you.